right. Good morning, everybody. We're going to wait for just a few minutes to let people come in from the lobby and be able to get logged in, and then we'll get going this morning. Greg, everything ready to go on your side?
Ready to go. Excited.
Yeah, this is the live event, you know.
Got some fun stuff to show today.
Good deal. Good deal. All right, we'll give it just a few seconds longer. There's still a few people trickling in from the lobby. All right. Well, I think we've got pretty much everybody from the lobby. I'm sure we'll have some other folks coming in, but we can go ahead and get started. So, mighty fine good morning, everybody. My name is Cale Harbor. I'm the product manager here at ACS. Want to welcome you to our launch event today for the new Cognex L4000, a smart 3D head that's got some really nice patented features that Cognex has been able to incorporate into it. That's really makes it a game changer from what we've seen in 3D vision inspection in the past. Joining us today, we have Mr. Greg Seal of Cognex. He's going to be leading the charge for us. Greg, you want to take a minute and introduce yourself?
Sure. All right, welcome everyone. As Cale mentioned, my name is Greg Seal. I work for Cognex, and I'm the direct sales engineer in the state of Georgia. So hopefully if you're in Georgia and you are familiar with Cognex, we met, and if not, we'd love the opportunity to meet with you. And then obviously we know ACS is a very strong Cognex distributor. They cover a few different areas within the Southeast. So hopefully some people from both Georgia and elsewhere as well. So really excited to get going. Today we're going to show the new Cognex 3D-L4000, a whole new way of doing 3D machine vision. Makes it a lot easier and a lot more robust. So we'll get into that here in a minute. Before we get started, I do have a quick question I want to ask everyone. And just kind of curious here is, how many people here have you ever used 3D vision? Are you familiar with it? Or is this going to be completely new? And Cale should be putting out a poll, so if you don't mind just checking, it'd be kind of interesting to see what we have here in terms of our audience.
Yeah. While we're waiting on those answers to come in, just want to go ahead and let everyone know I'm going to be moderating the chat room. If you have a question or something that needs to be addressed or need additional details for anything that Greg is showing, and I don't think I hit the publish button. There we go. It helps if I put it online. Got any questions that come in? Please put it in the chat room. I'm going to be feeding those questions to Greg. We're going to get through those as we move through the course of the presentation and get you whatever answers we need to. In addition, this event is being recorded today. So this is going to be published in our website library of webinars on demand. And you can actually go there and see a webinar that Greg and I did back in October during the launch of the Color Vidi system. We're also going to be posting this to our YouTube channel. So if there's someone else in your organization, or if you'd like to rewatch something, you can go to either of those places. If you visit our YouTube channel, please subscribe to it and follow it. We post content on a regular basis to be able to help with things like this. So Greg, the poll's coming in. It looks like just about almost 50-50. 55% of our audience has worked with 3D vision before. 45% has not. So it's almost an even split of those that have and have not worked with 3D in the past.
Okay, awesome. That's great. We'll do some comparison to how 3D was done before this technology, how some of our competitors do it, and how some of our older 3D systems do it. And then we'll compare also what makes this camera a little special, and maybe go over some of the basics for those that are not so familiar with 3D. So with that being said, let's start it off. I am going to kill my video, and I'm going to share a screen. I'm going to be turning over and playing with my camera, so I don't, watch you have to stare at the side of my head, and all the good stuff's going to be on the main screen everywhere. So, Cale, is my screen showing up now?
Yes, showing up very well, Greg.
Awesome. So, I do have a quick introduction to the product. I want to kind of go over some of the basics, and then kind of, again, what makes this product a little bit unique when we're talking about 3D vision. And then we're going to get into some live demonstrations and start playing with the camera and get into the really fun stuff. So here we go. This is the Cognex In-Sight 3D-L4000. So anyone that's familiar with any of our In-Sight cameras, whether they be the 2D and now the video deep learning, this is going to be a very similar environment. It's going to run actually in the same software, the In-Sight Vision Suite, which the Cognex D900 video camera runs, or deep learning tool sets run in the same environment. So if you've used any of those or familiar with those, this should be very quick to pick up. But yeah, I mean, this is the camera, and what's great about this 3D camera is we've brought 3D to the In-Sight smart camera platform. So previously with Cognex and a lot of our competitors also require a controller or a PC, where this is not like that. This is an all-in-one smart device. It's a smart 3D camera. As you can see right here, basically this is your vision system. So very lightweight, very compact, and very powerful. As you can see here, this is just showing an example of the ARM processor. Basically, ARM processors are for embedded systems. You know, the iPhones use ARM processor, things like that. This is an 8-core processor, so a lot of horsepower in a small device, and it does full 3D point cloud inspections. And we'll get into what a 3D point cloud is and what makes it a little different here in a minute. So yeah, I mean, this is the camera, like we said. Some of the features in it, it does have the Cognex HDR, and so to speak, what that really does is, what happens with these cameras is they portray a laser line, right? And that laser has an imager looking at that laser, looking at displacement, and as the product moves under it, it builds a 3D image. So in the past, some of the limitations in 3D is the color of your laser line, right? So like if you have a blue laser line, you're looking at a red part, that red's going to look really dark to the blue laser. That's just kind of optics and physics. What we've done with HDR is we kind of negate that, and we're able to manipulate the information in the vision sensor to improve our contrast no matter what the color is. So that's a huge advantage here. Again, this has got a 2K line scan sensor on it that's looking at that laser line, 4 kilohertz scan rate, twice as fast as our previous 3D. And then the most, I think the biggest advantage or the biggest jump in our technology here is the patented speckle-free blue laser. Basically, put it in layman's terms, it's a pure laser. It doesn't have any speckles or dots. It's continuous all the way through, and it gives us a beautiful image. And we're going to get to that here in a minute. And again, same ideas with your other In-Sight cameras. You've got an X-coded Ethernet port that would go to your PLC or PC, and then you got a power and I/O cable that would, be a flying lead to a 24-volt power supply, your encoder pulses, maybe some inputs and outputs. So yeah, let's take a look at this. I mean, the idea here is we are making 3D easy as 2D, and I'm going to show that when I jump into some of the tools. But to speak on how this is a little different than maybe some other 3D systems that you're used to, and ours included, is typically with every other 3D system out in the market, they compile a 3D image, and then they convert it to 2D when they do some inspections. So that could be a heat map that gives some height information, or a cross-section that gives a transition of depth, or something along those lines. Well, we're doing it completely different here at Cognex. We have a full 3D point cloud and 3D vision tools. This is something that's completely brand new in the industry, and brings a whole new depth of what you can do with these tools. And with that being said, guess what? We also take a 2D image as well, and we can do all of our 2D inspections just like we could with the previous 3D. So we're kind of getting best of both worlds with this system. So this is just an example of the really nice clean image you can get with the speckle-free. You can see very smooth transitions, no spikes, gaps, things like that. Again, this is a patented laser that Cognex has the rights to, that we've helped develop, and we're putting into these cameras. So brand new true 3D vision tools. I'm not going to jump into these specifically today, and I'm also not going to be showing the kind of example demo that we have. If it's something you want to look at some more tools that you're seeing here, contact myself, contact ACS. We would be happy to go deeper. Some of the tools I'm going to show today is really to highlight the 3D blob tool. I think it's a very powerful tool, and I want to show how we can use one tool to get the most out of it. And I'm going to kill that, and let's jump to the next screen. So here's just a quick example showing the 3D tools. This is just we're extracting a sphere here. We're finding an indent in the part using the 3D blob. We can find the plane of this triangle here, and then we can compare angles. We can find edges. We can extract a cylinder. So there's a lot like we can show here, this one part that we can do. But again, for time's sake, we're just going to highlight some of the key features today. So here's a list of all our 3D tools and 2D tools. I'm not going to go in one by one, but one thing I do want to point out with this is this camera has the complete In-Sight 2D tool set. So these are the Cognex developed 2D algorithms that we have spent the last 40 years developing. You get all of these with this camera with our brand new 3D tools. So again, it's a very, very powerful system and a very small compact device. Okay, so before we jump into the demo, I do want to explain a little bit about how these cameras work, especially for those that may be new to 3D. Again, so we mentioned this blue laser line gets shot down from the camera, and I'm going to show you that here in a minute live with my camera. But what's important to understand is all this information with these dimensions, right? So one thing that's really key is you have this working section, this trapezoid here, and this is kind of your sweet spot. Anywhere within this range can be used to image. So as long as you get that, it's called the clearance distance right here. And for the camera we're looking at today is the 4100. So my camera has to be at least 130 millimeters from my part. And then that whole range here, which is our measurement range, 235, we have that much area that we can see within. And then if we go to the bigger one, this LD4300 is 3/4 of a meter. I mean, so that's a pretty big field of view that we get out of this. And the laser kind of portrays out, as you can see. So it kind of makes that trapezoid, and that's just the physics of the laser and the imager. Typically, higher up in your working section, you're going to get better accuracy. Lower down, you get a little worse because you still have the same amount of pixels, whether it's up top or at bottom. Now you're just spreading those pixels out over a larger distance. So obviously, resolution goes down a little bit. Again, if you guys want to see a little bit more about accuracy, repeatability, linearity, we have all that information in the data sheet. Contact myself, contact Kale or ACS. It's also on the Cognex website. So it should be pretty easy to get. It has a lot of information in there as well, but this is just the basics. So with that being said, I'm going to switch over now. And I guess real quick, Kale, do we have any questions?
Yes, Greg, we had two that came in. One customer asked, does the head actually scan or does the target or camera need to physically move? And I answered that back. The message was sent to me and I've answered it, but I thought we'd do it for the group together. We do have to have either the part moving or the head moving with an encoder feedback in order to generate the image very similar to a line scan camera.
Mm-hmm.
Exactly. The other thing I wanted to make sure that we pointed out, I know you showed that we can do both the 2D and the 3D tools within this one head. Greg, are you going to show how we can actually inspect the intensity image like we would with the traditional 2D camera as well as the 3D image?
Yes, we'll get that. So right now I'm going to show the ease of setup and just do some basics in 3D. And then I've got a pre-developed program for you guys that I'm going to show, and we can kind of dive into as much of that as you like. I don't want to do any spoilers, but there might be some 2D inspections going along with 3D. So we'll definitely get into that.
We're good to go.
Awesome. Okay, so what I have to start off is just a blank canvas. One of the really nice features of this camera is the ease of use. I mean, again, we're inside. We're using spreadsheet programming. Majority of people that have ever used a computer know Microsoft Excel or at least familiar with it. So this shouldn't be like ladder logic or C++ or anything that's completely different than anything you've ever seen before, right? So what we got here is 2 cells. This is going to be our 3D cell or 3D image, and this is going to be our 2D image. They're airing out because we don't have anything yet. So to start, I just double click, or I can just go to my acquisition page here. This is my trigger information. The only thing I'm going to change is I'm moving from lens to laser and sensor. So this is going to be the raw, we call the raw image, as you can see here. And this is where I would set my exposure. The exposure is basically how much light or how much time we allow light for the sensor to take in. So higher exposure, slower you can go, but brighter image. We could do HDR, but for this, I'm just going to hit auto. And when this goes, I'd like you to take a look at the bottom right, and kind of you'll see that laser. You should get a little bit brighter there, and you see how it's going with different functions. What it's doing is it's going through different intensities and just picking out the ideal one. So again, very easy, does it for me. So this is my measurement range that I showed that trapezoid here, how high and low I can inspect. What I can do is I can close it down to make it run faster. And so now I'm only going to be looking in the zone where my part is. This is my height, and this is that laser line. Everything looks really good here, so I'm going to move on. So this is a really nice feature that I'm going to show here. And this part is actually a calibration block that you can purchase with the camera. And what I'm going to do is I'm going to put it down here. I'm going to tell it, I'm going to unlock it because I want to recalibrate. And as you can see, I've got 3 different options. You know, they go for the 3 different cameras. You can use them with other ones, but these are optimized for the camera. So I'm using the 4100, which is the middle of the road, the middle field of view. So I've got the middle calibration block. So my camera here, and I'll switch over to just a quick webcam view, has got the external Ethernet that's going to my PC. So I'm programming on the PC, but you know, once you program and connect it, you can put your network switch, your PLC, however you're running it. And then I've got a power and I/O cable here. And this is actually running to a 24 volt, but it also is an encoder that tracks my movement here. But guess what? I have no idea what the encoder pulses are in my encoder. So I don't know how to do the math because I don't know what my CPR is. That's fine. That's the purpose of this calibration block. So what's going to happen is I'm going to grab one and perform a correction. So I'm going to scan this block in, and while I'm scanning it, my camera is actually going to listen to the encoder pulses as the part is moving, and it's going to optimize the settings based on this calibration block and the number of pulses it receives. So no more encoder math, none of that, you know, hard math and complicated calculations to do. I have a grab one form correction, and then I'll just scan it. I got about 6 seconds that I set it to listen for. Looks like that should be good. And there we go. So you can see my part looks pretty scrunched up, right? Well, that's because it hasn't done any math yet. So now it's processing and it's calculating based on what it received to optimize this to make a 1-to-1 pixel. And there we go. So look at that. You see how that went out? So now what I can do is I can jump to my point cloud and I can say I want to scan for 150 millimeters. Okay, so that's my length. And then I hit auto, and that automatically sets my by resolution. So I have a square pixel with my encoder ready to go. The next one we could go to would be our filters. So we could do gap filling, medium filter, spike removal. As you notice, there's a lot of blank space here, and that's because there's a lot more that are going to be coming to this camera as well. This is really just the beginning of this fantastic technology. So we're ready to go. I mean, I think we look pretty good. Let's jump into our spreadsheet. And I'm going to kind of split my screen over here. It's halfway through. I'm going to put my camera in view, my parts in place, and I'm going to hit the trigger button, tell my camera to start taking an image. You see me scan it. You see that beautiful blue laser line. And see my 2D image behind my spreadsheet there. And there we go. So there's a nice, clean, crisp looking 3D image. Look at that. That's the speckle-free laser. We can change it to color for the heat map. Make it nice and smooth there. Let's do this. And there we go. So again, this is just a bar where I can adjust my color scale if I want. You know, if I want to bring it down a little bit. So you can kind of adjust that as you want. Really just for looks. I think that's good there. I'm going to remove that, and then let's take a look. So 3D imaging, just like that. I mean, what was that, 5-10 minutes? So let's, I'm going to jump to a bird's eye view, and I'm going to add a 3D tool. I want to show you how easy this is. I'm going to go to Tool, let's go to my spreadsheet, select the cell, 3D Vision Tools, 3D Extract. Let's try Edge Tool. I'm just going to drag and drop it in there. You can see it made a region. It already has a tool, but I'm going to set my own region. So I'll double click on region, and I'm already in bird's eye view, and I've got this quick draw box. And all I need to do is drag it along, maybe rotate it. Let's go there, hit enter. Let's see what we find. So we found an edge. I'll dive into what's going on here in a little bit. Let's see how many edges we can find. There we go, 6 edges. So what are we doing here? We are scanning from this direction, as you can see my red arrows, across, and we're looking in transitions in depth. So I found an edge right here at the bottom where my part is to the floor. Again, where my part again goes over to this base plane. And then as we go up, the trapezoid here. And you can see it all the way down. There we go. So that's an edge tool. Look at all those edges. Found 6 of them. You know, 1, 2, 3, 4, 5, 6, 7, 8. Excuse me, 8 of them. Starting with 0, 0 to 7. So we've got our edges. Let's say we wanted to start to find some information. Let's say I want to find the width of my total part. So I can see in order of position, you can see that's how they're set here. I can go, I want to measure from from line 1 to line 6. So what I will do is a 3D measure, and we will do a point to line distance. Again, just going to drag it over. So each edge creates what we call structures. It creates a line 3D, so those are those lines we're seeing, and a midpoint 3D. And we use these structures to do measurements. So what I'll do is I'll just grab the point. It's going to be the midpoint of, I believe it was line 1. And I believe it was line 6. We'll do line 6. And there we go. I'm going to hit OK. That is my measurement. So we're going here all the way across. That is the width, about 51 millimeters. One other thing I did not mention is this camera comes factory calibrated. So there's no need to calibrate into real world units or anything like that. This thing is going to spit out it's going to spit out millimeters, not pixels, out of the box, ready to go. So really nice feature. So we can do so think about any kind of edge you could pick up. We could do the measurements on that. I could do from the face if I wanted. But let's say you want to get the height of this. Let's look at one more tool here. And what I'm going to show is the plane tool. So I'm going to extract the plane. So I drag it over. And there we go, my region's built. I'm going to double click region 3D. I'm going to jump back into bird's eye. I really like doing that for my first programming or first tool setting. And then I'll go to quick drop and I'll go here. And so what I'm doing is just find the floor, finding my conveyor. So I'm going to hit OK. Another thing I could do is jump to a side view. So you can see this over here real quick. We kind of see what we've done is we've made another structure. This structure is going to be our rectangle here, right? That's our plane, that's our floor. And then it also does a point again, which is the midpoint of that plane. So again, we'll do one more plane, drag and drop, and double click region. I bet you can guess where I'm going next. Bird's eye, quick drop box. I'm going to zoom in and just put it right there in the middle. Let's see what we get. All right, hit OK. And there we go. So now we have a structure that is the base of the top of our part. So, do you think we can find the height of this part now? I think so. Let's look at our 3D measure tools. Point to plane distance. All right. So I'm going to drag that in. And external point, same idea. Let's just grab that point we just added. And then to plane. Go to our plane. And there we go. Hit OK. I can go to my side view, and I can see I am going from the floor right here. Remember that floor of my conveyor to the top of my part, and it looks like my part's about 15 millimeters, 14.93. So yeah, that's the plane tool. That's the edge tool. I mean, what was that? 10 minutes? We got set up. 15 minutes. So I do have one more demonstration that I will jump over into a full program. But do you have any questions at this time? Anything else you want to go over while we're looking at this part?
Yeah, we had a couple questions come in, Greg.
Okay.
So we had the question, can they use the device without an encoder? And because we have customers that are looking to put it on a robot-based application. We can do a time-based scan on this. It does not have to be an encoder-based. Isn't that correct, Greg?
That is 100% correct.
Yeah. We actually use that very commonly on our robot applications because when we mount this on a robot where the robot is moving the head, we can control that speed very precisely, and we actually get very good images off of it. We also have the options, depending on the robot brand, if they have the capability of sending us a pulse stream, we can bring that pulse stream into the encoder inputs as a potential as well. But doing time-based on a robot application works very well, and we've had great results with that. Another question we have, I don't know the answer off the top of my head on this one, Greg. What is the resolution in the middle of the field of view?
So that's a very good question. And basically we would need to do some math for that. Let me see if I can throw this back up. And I can help with that if anyone wants to speak later about this. But basically we have the resolution and the accuracy up here in the data sheet. And
hey, Greg,
yes.
Could you turn your webcam off? It's hiding the table.
Oh, thank you, Kale. Yes, I definitely can. So let's do screen only. There we go.
There you go.
Better. Yeah, so this would be something we'd have to look at the data sheet for. If you just want to see what the field of view is in the middle, that you could basically interpolate that between this. But it would just be a linear equation where we would say, hey, we know what our field of view is up here for our accuracy. We know what that is here. And it's a linear equation. We would then put in where we want that field of view. And then we'd do some math to find that out. Again, something I can help with offline. But it's a pretty simple equation. We just compare the value between the top and the bottom and then enter in using that factor to find the middle.
Okay, we had a clarification to that comment. They actually meant what is the accuracy in the middle of the field of view versus the resolution.
Same thing. So we would do the same thing. That stuff's all in the data sheet. I'm not going to jump into that today, but there is the data sheet at the top of the field of view and the bottom, and we would then interpolate to find whatever position you want.
Okay,
so
basically,
it
is linear between the minimum field of view and the maximum field of view. So it's a perfect linear relationship. So if I took the minimum and maximum, very simple math, I can calculate what the midpoint is for the accuracy.
Yep. And again, contact ACS or myself, and we'd be happy to help you, show you how to do that, and kind of work based on your application and come up with that information. So.
All right, we're good to go, Greg.
Okay, before we switch over, I know there are some questions about the 2D image. So I am going to show this here. This is a really nice feature of the software, is we can look at 3D over here, and then I can look at my 2D and look at that. I mean, it's a very clean, crisp, focused image, and it's going to be focused anywhere in that sweet spot, which is another huge benefit over just standard 2D. So I did want to show that. Okay, so I'm going to switch over to the webcam. I'm going to open up a pre-configured job on my end. I'm not going to show my screen for that just because I have some customer examples in my camera. And since we're in a public webinar, we want to avoid those for now. So as I load up, we will switch back over. And there we go. So we've done that. We kind of showed how we get the depth in the full 3D. Well, now what we're going to do is we're going to look at what kind of accuracy this thing can get. I want to look at a Cognex business card. It's a little bright, but you'll see it over the camera here in a minute. And I also want to show the web HMI. So I'm going to jump out here, open my web HMI, and let's drag this into the screen. And what I need to do is kill my development page and load that up. Refresh real quick, and you should see it. So this is our web HMI. I know my screen's cutting off a little bit here, but there's nothing that you're missing down here at the bottom right. What I'm going to do real quick is hit trigger once so we can take an image. And there we go. So the web HMI, it has a 3D image. You can see the business card. I can see my film strip down here, so we can go look at past. And then what I've got hiding, I guess you've seen this now, what I can do is just show the full screen, is we can jump over to a measurements page. Oops. And we have the page, the card, and now I've got a bunch of different measurements, okay? So this is one tool. So all this is the 3D blob tool. We're pulling height, making sure that it's within this range, minimum and maximum, and I can adjust these values here. So we could put this up to, let's say, 1.1, and now we fail, right? But we'll go back to 0.9. We're finding length, same idea, and width, and same idea. So let's say we get our card, and say we cut off a little piece for it, right? So I'm going to just kind of cut off some of, let's call it right there. And let's put it back down. And let's see if the tool can find it. So our card length is 86.742. I hit a trigger. And still within our spec, so that's good. But, you know, if we were over at our spec in 83, that would fail. Whoops, I can type it in right into it. So I'd fail. Another thing we can do is maybe just cut off a little bit more, so we actually do fail it. Let's try that. Trigger once. And now we're at 73. So looks like our stage fell off, but that's fine. It's very modular. Put that back on. Let's try another one. So we're going to scan a card again. It should be a good one. Let's see what we get here. Everything is good. Now what happens if we have a little corner sitting up? Let's see this. And now our height failed. So look at that. Again, power of 3D. See, the camera's got a nice, beautiful image, picks it up, and now that's 3.67 millimeters tall. That is a fail. So again, we can do one more. Let's say, maybe the X and Y is good, but we got this corner, right? So I'll show the screen back up. So we've got this corner cut off now, a corner, right? So our max X and our max Y might be good. Let's see if the blob tool can find that. And I will trigger once. And it looks like the volume is still good. Let's try, let's maybe readjust our settings, change to 3000, and pass and fail it. So what I want to do now is jump into the software and show what we're doing here. So you can see I've got a very small, skinny 3D image. And missing a part there. This is my blob tool. And as you can see, what it's doing is it's picking a bounding box, and it's getting the max length and max width, all with this one tool right here. This is all our results, and then it's doing the total volume of what's under it. Very powerful. You can see the region is looking over the entire conveyor here and just picking out what's in there. What we can do is kind of cut this one again and take a look. And you should see this is how the blob tool is able to pick up just what's on the conveyor. And again, remember, this is a 1 millimeter tall card. I mean, our height is 1.3. Again, what's going to happen is the card's lifting up. As you can see, as I cut it, it kind of flares up a little bit. So it's very small amount of material there, but we're able to kind of reliably pick that up. It says the length failed, 73, and the volume obviously is much lower as well. Now, I think we also mentioned 2D. So let's jump over to that and see what we've got over here. So what I'm going to do is I'm going to go ahead and scan one more good card. Let's set up some 2D tools real quick. So we'll scan again a good one. I'm going to make my image big. So that looks pretty clear, right? You've got a nice, pretty crisp, clean image there. Again, we can make this a little lighter if we wanted to with HDR, but for today, we're just, we don't really need it. So let's go in here, and I'm going to teach my pattern. So again, this is 2D PatMax. The camera also does have a 3D PatMax as well, which is very, very powerful, but we didn't really need it for today's demonstration. But if you need a fixture in 3D, it is definitely possible. So I'm going to hit enter. I'm going to train it. It's going to train my pattern. So we're finding that Cognex Corporation now. Let's go big. Let's go to our pattern tool. And there we go. Looks like the region's got a little too big back there. And let's see, now we're doing OCR as well. Wow, look at that. So not only can we do full 3D measurement inspection, we can also do OCR and read text with this. So I'm going to go back online. Let's take a look, jump back to that web page. And here we are. We'll jump back to our measurements page, and we will trigger once, and let's take an image and see how this looks. So trigger once, scan my card, and now it's able to say whose card is it anyway. Looks like Greg Steele. And now what I can do is actually display results. So we can look at everything. We can see the 2D image, reading the text, and now I can. Looks like I might need to do a refresh here. Let's go back, and then jump to our measurements page, and now we can see the blob tool as well. So, what happens if we put someone else's card in? You think you can read multiple people's names? So I've got one of my coworkers' cards here. I'm going to put it in and trigger. And there we go. OCR, able to read text. We're doing full measurements. And then, let's take it one step further. Go back into our spreadsheet, and what I'm going to do, see if we can read this QR code. So I know the read ID max is our, oops, gotta put my parentheses, and get my region, throw it over that, tell it I want to read a QR code, and there it goes, www.cognex.com. That is the string. So we're doing OCR. We're doing 2D codes. We could also do an edge fit tool there. A lot of great stuff that we can do in 2D or 3D. So with that being said, are there any other questions, comments, anything else anyone wants to see today while we're all here together?
Yeah, Greg, we got a couple things. We just had a person ask if the card is rotated 180 degrees, can the camera still identify the name? I would assume that the pattern tool behaves here just like it does in our normal In-Sight product where we're able to handle that rotation?
Yes. So we would have to set that find 180 degrees. Let's give it a shot, see if we can do it.
We're putting you to the test live.
Yeah, I haven't tried that yet. That's a good question. Let's see.
We'll either be successful or crash and burn.
Mm-hmm. And look at that, OCR Max still picking it up. So we can do 180 degrees. PatMax 3D is also capable of doing 180 degrees as well.
All right.
Yeah.
We had two other questions come in. And one was, does this unit behave like the 9902L line scan? And it does indeed. This is a line scan product. And the laser light is the light source to be able to work off of. So you've basically got a line light coming down on your part. The camera is watching that line to be able to get the 3D triangulation and create that 3D image. But it basically behaves just like the 9902L. But while we're on the topic of the light source, and here's a cool question, and Greg, I haven't heard you touch on this. Any issues with metallic material or polished materials? And I think there's a new patent associated with this we haven't talked about yet.
Yeah, that is a great question. And that's kind of where that HDR plus the blue speckle-free comes into play. It does image metallic material much better than our previous 3D technology. Obviously, I can't speak on anyone else's, but I would be willing to put ours to the test. So that would be something where I would say, hey, if you got some metallic parts and want to look at it, contact myself, contact ACS, and let's evaluate it and see what we can do.
So basically, there is a new patent that Cognex has regarding the imaging system of this camera, working with this blue laser line and the imaging processing chip that almost completely eliminates specularity. So where in the past where we've had a polished or metallic surface and you wind up having the light reflect in all sorts of strange ways and you wind up getting data points totally unrelated to your part, this is almost non-existent as far as that specularity is concerned. We're really able to get a nice clean line even on metallic parts. It's not 100% eliminated. There are some cases that it might still become an issue. But like Greg mentioned, if you've got parts, send it to us. We have this equipment going into our labs and would be able to help test the part and be able to get sample images back to you.
Again, that's a lot. We're working. That's one thing also we're working to improve on. It is really good out of the box today where it is, but like I said, we've got some more filters these included, but then more to come that will just come in firmware and software upgrades. So what's really great is this is really just the tip of the iceberg of this technology, and I think you're going to see a lot more being added to this over the next few years as Cognex continues to increase the use and the capability of these systems.
Okay. All right, Greg. We don't have any more questions in the chat. We have something going on today here at ACS that we don't have going on every day, especially over the last year. I was going to share with the group right quick. So I'm just going to share my screen for a moment. And Greg, if you could let me know if that's coming over all right.
Looks good.
All right. Many of you may know, or have, at least in our marketing that goes out, know that we are a strong proponent of providing training. We're one of the very few certified Cognex training centers at a distributor level for the Cognex product. We happen to have a Cognex In-Sight 4-day programming class just began today. So this is actually a live shot of our training room. So I wanted to just make everybody aware, even with the whole situation that we're in requiring the social distancing and what's going on, our facility is set up where we're maintaining distances on everybody. We are at a full stadium seating. We're maintaining the separations, one person to a desk type thing. So we do have some classes that are still going on. As you can see here, we're limiting the number of people, and we're limiting the spacing between them, and we're taking the necessary precautions to make sure we still get the correct training opportunities out there for our customer base. So with that being said, I have got one more poll that I wanted to be able to throw up. Are you interested in attending a 3D training class? So if we were to set up a class here and we were to bring Cognex in to help participate with this, would that be something that you would be interested in actually coming on site and attending, knowing that we're going to take the right precautions with it? So far, the number of respondees that we have to the poll, Greg, is we have a 100% yes category.
Awesome. I love it.
Yeah. So with that being said, I don't currently have a 3D class on the schedule. Oh, a few more people have come in. Okay, it's 50-50 now. So we do have the ability to social distance. We do have the equipment coming in. It is something I can look at. But Greg, I may need some help putting the curriculum together. Do you think you could help me out with that?
Definitely.
All right.
I do see a couple of questions here, Cale.
Yeah.
It looks like another Greg asked what model. Just to answer that, it's a 4100. So it's the middle resolution. Again, the data sheets on Cognex.com has a lot of information in accuracy and field of view. And then Paul asked what ACS location this is, and Cale's in the Marietta location, and I'm at my home office today. So, but that's what he's showing you in that training area.
Yeah, so within our Marietta office, we do have a full automation lab set up, and the automation lab is actually set up right behind the training classroom. So I'm not going to open the double doors to be able to interrupt the class, but this is where I'm located at. And I'll just go ahead and, once again, I'm going to test fate to the wind. I had not previously decided to log into this camera, but I'll go ahead and show a little bit about what we have going on, provided my connection behaves. There we go. So in our Marietta facility, we actually have a dedicated 1,200 square feet of space set aside for training, hands-on work, and automation testing and feasibility studies. And I'm just waiting for the image to pop in. This is located right behind our main training room. So the main training room is where we do our lecture-based portion of the class. We provide the classroom instruction, work with the simulators, and we work with the programming aspect of it. Then we would come back out here into the actual automation lab for the hands-on portion of the class. So this is where I'm at. You can see where I'm set up here. I hadn't cleaned up the place.
I think you need to lower your video a little bit. I'm only seeing the ceiling. If you're trying to show more behind you.
I have adjusted it down. We might be dealing with a little latency.
Okay.
But at any rate, we have the room set up. We are able to do feasibility testing. and this is Marietta office. We're currently in the middle of building out an expansion in our Spring Hill, Tennessee office. We're going to be doing a very similar size training room there with the stadium seating, and we will have a smaller version of this automation lab there. We have recently expanded both our Knoxville office. We don't have a space like this there yet. That could be in the future. And we have just opened up our Birmingham office, and that is so new. It's a much smaller training space, much smaller lab space, but we still will have the remote camera access there as well. So all of that's going to be coming. We're very excited about what the future holds, and we can do a lot of great testing here as well. So if you have parts or things to bring in, I encourage you to send them in. We can set them up in our vision lab. We can set them up back here in the automation lab, be able to work with you on finding the right solution to everything. So that being said, I think that is everything that I had going on. Greg, have you got anything else?
That's all. Appreciate everyone for joining, and hopefully you found it interesting, entertaining, and maybe learned a little bit.
All right. Sounds good. I wish everyone a great day. This is being recorded. We will be posting it on our on-demand library as well as our YouTube channel, and be sure to like us on YouTube. Thanks, everybody.